Am I good to start? Oh, there we go. Good morning, good morning. All right, here we go. Hello and welcome. Good morning. My name is Valerie Burke, and I'm the Assistant Dean for Graduate Student Services. And I am thrilled to welcome you to our 12th annual Rebel Grad Slam 3-minute thesis competition semifinals round. We would like to begin today by acknowledging and honoring the land on which we gather today. Let us turn our attention to the screen.
The University of Nevada, Las Vegas wishes to acknowledge and honor the indigenous communities of this region and recognize that the university is situated on the traditional homelands of the Nuwuvi Southern Paiute people. We offer gratitude for the land itself, for those who have been stewarding it for generations, and for the opportunity to study, learn, work, and be in community with this land. We encourage everyone in the UNLV community to engage in continued learning about the indigenous peoples who work and live on this land since time immemorial, including the Las Vegas Paiute tribe and the Mawapa Band of Paiutes, and about the historical and present realities of colonialism. As one of the most diverse universities in the United States, UNLV believes it is important to recognize and appreciate the use of Southern Paiute land as part of its mission to be a welcoming and inclusive place for working and learning.
The 3-minute thesis competition in 2014. This year is our 12th annual Research Rumble. The 3-minute thesis, or 3MT, competition model was developed at the University of Queensland in Australia in 2008. The 3MT is a fantastic opportunity for students to learn how to convey who they are, what they study, why they study it, how they study it, and what they found or expect to find, and why it matters to an audience of folks who are mostly outside their field. It's an opportunity to build public speaking and communication skills and to polish one's elevator speech describing what they study as graduate students. It is worth noting that our slammers come from all over campus and from a wide range of disciplines. It's a diverse pool of over 100 graduate students who have competed this week. Today, we have a group of UNLV graduate and professional students who have moved on to the semifinal rounds. Each will present their research in 3 minutes or less, using one slide and no props. We will introduce each student and then start the timer. If a student goes over 3 minutes, they will be eliminated from the competition. The judges will be assessing the competitors based on metrics which total 24 possible points in 4 major areas: comprehension, content, engagement, and communication. Each judge will independently score each competitor. At the end of the presentations, we will tally the judges' combined scores for each slammer and announce the winners. The top 3 in this session will advance to the next round. 9 students will then advance to the finals at 4 p.m. on Friday here in the Greenspun Auditorium. The top 3 grad slammers in the final round will be awarded scholarships in honor of their accomplishments. We will also recognize the slammer who wins the heart of the crowd in each semifinal round with our Audience Choice Award. So, audience members, make sure to scan the QR code for a ballot and cast your vote at the end of this round. We will tally votes and announce the Audience Choice Award winner along with the first, second, and third place winners immediately after this round. So, without further ado, let me introduce the judges and then we will get on with the Research Rumble. Judges, if you don't mind to please stand when I call your name, give a little wave. Dr. Kavita Batra, Assistant Professor in Medical Research. These are going to be really long. Do you want me to read all of them? Okay. I got you. Oh, there you are. Yay, thank you. Dr. Kendra McLaughlin, let's do Psychology Department and Grad Alumni Ambassador. Darlene Magna, Marriage and Family Therapy. Dr. Tara Emmer Summer, Associate Dean, Communication Studies. Dr. Monica Nita, Professor and Associate Dean for Research in Mathematical Sciences. Dr. Peter Kaufman, Professor and Associate Dean for Research and Office of Research. Dr. Nirja Bandra, Associate Professor, Health Admin and Policy. Niraj Padari, thank you, sir. And Dr. Sarah Suran, Assistant Professor of Early Childhood Education. So thank you, judges. We give them a little round of applause and thank them all for being here. We really appreciate y'all. Now, it is my pleasure to introduce our first speaker, Josie Lindau. Go ahead, Josie.
Hey, Malcolm Moore, can we go thrift shopping? Did you know you can go thrift shopping for drugs? Yes, that's right. We refer to these drugs as repurposed agents. So why are repurposed agents so important? Well, because today, Alzheimer's disease is the leading cause of dementia, affecting 7.2 million people in the United States alone, and 55 million people worldwide. Alzheimer's disease is a progressive brain disorder that results in cognitive decline. Did you know that 99% of all new disease-targeting therapies for Alzheimer's disease have failed in the last 100 years? The first new disease-targeting therapy for Alzheimer's disease was approved just a few years ago. Repurposed agents offer a fast approach to combating Alzheimer's disease because novel compounds take 12 to 15 years to be approved, and they often fail. This is time we don't have. As the population continues to grow, so do the number of cases of Alzheimer's disease. Novel compounds have to go through preclinical testing, while repurposed agents can go directly into clinical trials and only take 6 to 12 months for approval. It is estimated in the next few years, Alzheimer's research will cost the nation over $1 trillion. That's right, over $1 trillion. In my research in the Department of Brain Health, we analyzed important repurposed agent trials to determine what makes a successful phase 3 clinical trial. Phase 3 trials are when drugs are tested on the global scale. We classified drugs as patent or generic. Think of patent agents as finding a Gucci t-shirt in the thrift store, and generic as a UNR t-shirt. This work lays the foundation for what makes a successful repurposed agent trial. An example of a currently important patent repurposed agent trial is semaglutide. Many of you know and refer to semaglutide as Ozempic, which is known for weight loss and the treatment of diabetes. Ozempic is now in an active clinical trial for Alzheimer's disease. This trial is investigating how Ozempic can target neurotransmitters and reduce neural inflammation in the brain. In a few short weeks, we will know if Alzheimer's disease will be able to use Ozempic as a new treatment approach. Repurposed agents save valuable time and money and show promise in helping us understand the underlying mechanisms of Alzheimer's disease faster than novel compounds. So, before you walk into Gucci first, try your local thrift store. You never know what you might find. You might just have a new drug treatment approach for Alzheimer's disease. Thank you.
In between each presenter, we'll give about 60 seconds for the judges to finish scoring. Okay, we are ready for our next slammer, Thomas Crippen.
So NASA wants to hibernate humans for deep space travel, right? And I'm investigating the optimal conditions and temperatures in which to best facilitate this process. However, we all know that humans don't naturally hibernate, so I began my research by investigating an example of an exceptional hibernator, our cute little astronaut friend in the top right corner, the golden mantle ground squirrel. Ground squirrels undergo a unique form of hibernation, unlike bears who sleep for months on end, and instead they go to sleep for about 2 weeks, they wake up for a day or two, and they'll continue this cycle all throughout the winter months. During these hibernation periods, they're able to reduce their core body temperature to the temperature of your average refrigerator, about 36 to 37 degrees Fahrenheit. Additionally, they're able to reduce their breathing rate to as low as 1 breath per minute, which is exceptional. Now, as much as we know about the temperature and metabolic processes that occur in hibernation in the ground squirrels, there's still a lot of work that needs to be done to address the gap in the field about how their nervous system or their brain goes through hibernation. In my study, I specifically study a type of cell that's found in the brain and spinal cord called astrocytes. Astrocytes are star-shaped nerve cells that perform a lot of different functions in our brain and spinal cord, but ultimately their job is to keep a happy and healthy environment inside the brain and spinal cord. In my experiments, I subjected golden mantle ground squirrel astrocytes to a 24-hour temperature stress at a variety of different temperatures. On the left image, you'll see astrocytes that were kept for 24 hours at normal body temperature, about 98 degrees Fahrenheit. You can see that they have that unique star shape, and they seem to be interacting with their fellow astrocytes. And if you were to Google astrocytes, this image would be almost completely identical to it. If you look at the middle image, these cells were incubated at room temperature, about 72 degrees Fahrenheit, and on the right, at a very chilly temperature, the refrigerator temperature, about 36 to 37 degrees Fahrenheit. And you see at these middle and cold temperatures, they start to lose that star shape. They bring in their arms and legs in almost what looks like a cryoprotective state. Now, I know what you're thinking. These are cold mantle ground squirrel astrocytes. We know they're great hibernators, so how does this translate to humans? I am currently performing experiments on human astrocytes, performing 24-hour exposures, so that way we can begin to draw comparisons between the two and see if there is some capacity for human hibernation. By drawing comparisons between the two, we'll be able to over time determine, like our cute little ground squirrels doing in the bottom right image, just how low we can go. Thank you.
We are ready for our next slammer, Ashley Roderick.
Imagine walking into your local grocery store, into the frozen aisle. You open the glass door and you find Hidden Valley Ranch flavored ice cream. Next to it, Kraft macaroni and cheese flavored ice cream, because yes, these are both real products, by the way. What makes a consumer instantly grab one of these off the shelf while another walks right on by? That simple decision of what makes a consumer embrace a co-branded product while others don't is what my research aims to understand. Co-branding is when two brands come together to make a new shared product or service. This approach is increasingly common and becoming increasingly complex across industries from food to fashion. At the same time, marketers of today have more access than ever to consumer data, offering new opportunities to create informed, data-driven decisions on how to target and engage their audiences. But here's the problem. Co-branding research still heavily relies on limited sampling. And because of this, our understanding of how consumers react to co-branded products is still based on a narrow slice of the population. And with this, co-branding research tends to treat all consumers the same, But what's missing is the recognition that people bring in different identities, experiences, and backgrounds to every purchase decision that they make. My research brings an intersectional lens to co-branding, putting the consumer lived experience at the center. Instead of looking at attitude and purchase intention as a straight line from awareness to buying, I argue that these interact circularly, consistently influencing each other based on who the consumer is and the context that they're in. Instead of in understanding why and with whom certain collaborations resonate with, will give firms valuable understanding on how to spend their resources, while consumers will get products that they actually want to buy. In conclusion, my research looks to advance co-branding theory into a new era, because when we understand the person behind the purchase, co-branding stops being a gamble for firms and can start being the strategy that it's meant to be. Thank you.
Okay, we are ready for our next slammer, Maria Palapa. Thank you.
I want to ask you all if you were breastfed. And if you don't know, find out why not. And if you were, find out what motivated your mother to breastfeed. I'm here to share with you my thesis research on breastfeeding and food insecurity. Breastfeeding is one of the most secured and healthful methods of nourishing an infant, especially in the early days of life. The World Health Organization recommends to exclusively breastfeed an infant without no other liquids or solids for the first 6 months, and then up to 2 years in conjunction with other complementary foods. We know that breastfeeding can be an optimal food and nutrition way of feeding an infant, but it may also be a strategy to protect them from food insecurity. There's lifelong benefits that go from breastfeeding contribute to both mother and infant. This can be strengthening the infant's immune system, defending them from illness and disease. This could be reducing the mother's risk of ovarian and breast cancer, ultimately saving over 500,000 lives a year. But yet, not all mothers and infants can gain these benefits, and it could possibly be due to food insecurity. Food insecurity is known to exacerbate disparities during pregnancy and early life in maternal child health. And we know that food insecurity, along with these additional maternal hardships, can interfere with the mother's decision to breastfeed due to the worriedness of their quality and quantity of their milk supply. Now, imagine today's food shortages, right? We're all experiencing them. Out there in Las Vegas, we have mothers with children under 24 months who are limited income, who are not receiving maternity paid leave, whose WIC benefits are depleted, who may or may not be married and have that support. All of these can influence that decision and can play a role. So my research is focusing on whether or not food insecurity is associated with the discontinuation of breastfeeding practices here in Clark County. My data comes from Clark County, and it's important because we already see here that we're not meeting the 2030 Healthy People goals nationally or at the state level. It's important because this is, to our knowledge, one of the first that is looking into breastfeeding and food insecurity along with these additional hardships. And it's mostly important because if any of you have infants or any of you are planning to have families, you want to know where you're gonna get that support and why it is important to breastfeed or not when you have a baby. Thank you.
Okay, we are ready for our next slammer, Catherine Oberg.
Close your eyes and imagine you're taking a bite out of your favorite cookie. If you're anything like me, you're imagining a warm, gooey chocolate chip cookie with just a hint of sea salt. When bakers are creating these culinary masterpieces, they will use a specific ratio of flour, butter, and sugar in order to achieve the taste and texture outcomes that they desire. For example, if you add too much flour, the cookie will rise, but it will turn out dry and crumbly. If you add too little flour, the cookie will fall flat and have a crunchy texture. The human genome is a lot like baking a cookie. You can think of our DNA as the recipe and the nucleotide sequences that make up our DNA as the ingredients. These nucleotide sequences often occur in repeating patterns called tandem repeats. It's very common. However, when the ratio of these tandem repeats double, triple, or even quadruple in size, that's when disease can occur. Many neurodegenerative disorders, such as Huntington's disease and muscular dystrophy, are caused by these tandem repeat mutations. So, what does this have to do with autism spectrum disorder? Well, 36% of children born with myotonic dystrophy, which is another of these tandem repeat mutation disorders, are also diagnosed with autism spectrum disorder. And earlier this year, my lab made an important discovery in connecting the molecular mechanism that connects these two. You see, what will happen is that a certain RNA binding protein will bind to the exact sequence that is contained within these tandem repeats. And so when there's an increased ratio of these repeats, there's also an increased ratio of proteins binding to those repeats. And as a result, they're stuck, and they're no longer able to bind and interact with other genes that they usually interact with. These genes become misregulated, and they go on to create a ripple effect that eventually leads to altered brain chemistry. And you might have guessed that these misregulated genes we've also discovered are connected to known autism risk genes. So what about other tandem repeat mutations? Well, currently I'm using computational and statistical tools to analyze individuals, sequencing data of individuals with different tandem repeat mutations within their genome. I'm then identifying the misregulated genes that are affected as a result. And then I use those misregulated genes to create a statistical comparison to compare them to autism risk gene data sets discovered by geneticists around the world. So far, the statistics are significant, but I still have a lot of work to go. But it is my belief that if this hypothesis rings true, then we are on the brink of discovering the secret recipe that contains the genetic recipe for an autism-flavored cookie. Thank you.
Number 6. Okay, we are ready for our next slammer. Renee Olney.
In everyday America, life hums along. UNLV students arrive on campus trying to survive another semester, but out of sight, a monster is looming. It is bound and under careful watch, but it continues to grow. That monster is called UF6, but for this story, we'll call her Scary Boo. Now, Scary Boo can be a bit dramatic. She likes to eat through stainless steel like it's Halloween candy, which is why she's kept in Teflon containers that are bolted closed. She can become ghost-like, a vapor drifting in the air. And when she mixes with water, she produces a poison that makes everyone want to run for their lives. Oh yeah, and she's radioactive. The way we currently deal with Scary Boo is actually to force her into the water. Then she has to be treated again because now it's a new monster and it's in the water. Thanks to scientists at UNLV, we now know that Scary Boo really enjoys salt baths. Here she becomes calm and she no longer causes harm to those around her. But everyone knows bath time can't last forever. We can remove her from her salt bath as a renewed form, Happy Boo, or UF4. Now she's no longer the villain in the story. Yeah, she's still radioactive, but what kid doesn't seem a bit radioactive now and then? Now she can be used as a nuclear fuel or as a precursor for nuclear medicine. My job is to figure out how to maximize the amount of Happy Boo we can recover from Scary Boo. We know that if we add water to her salt bath, she's split between going into the water and becoming Happy Boo. I found that when I mix her salt bath vigorously with water, I lose a significant portion of Boo to the water, about 40% just gone. But when I mix gently or not at all, I can recover over 90% as Happy Boo or UF4. I also wanted to see what she looks like under a microscope. And what I saw, because her shape will affect the way she interacts with other materials. And what I saw is that she's composed of these tiny needles that grow from a point, like a broom with dust in it. Now we're investigating why there are different shapes in Happy Boo. Turning Scary Boo into Happy Boo isn't magic. It's careful science, attention to detail, and respect for what's dangerous. Some monsters can become friends when chemistry lends a hand. Thank you.
We're ready for our next slammer, Lucas Richardson.
Is very much so like a puzzle with missing pieces. And that's not to say that we don't understand anything about the disease. In fact, to say that would be completely untrue. You see, each and every one of these puzzle pieces on the board here behind me contains a hallmark of the disease. And these have come from years and years of scientific research and discovery happening in labs all around the world. And you may recognize some of them, things like the protein aggregates, the amyloid beta plaques and tau tangles that form the brain that we've now associated with the disease. Connectivity changes, physical changes in the neural circuits in the brain that then result in some of the memory deficits that we see in our loved ones who suffer from this disease. Even things like metabolic dysregulation and inflammation in the brain all play a part in the disease pathology. The problem is that when scientists look at trying to come up with treatments for the disease, they often do so with only a few of these puzzle pieces in front of them. And as we all know, it's notoriously difficult to try to solve a puzzle if you don't have the full picture. And so that's what my research aims to do. I'm looking at creating a lab-based model of Alzheimer's disease so that when we do something like creating treatments or doing drug discovery, we can do it with the full picture in front of us. Now, the model I'm looking at doing this in is something called a cerebral organoid. It's a little bit of a weird term, but really what it is a clump of neurons that can be formed from any cell type in the adult human body. This means you could take skin cells or blood from a blood draw, and through a whole series of genetic manipulation that I certainly don't have the time to talk about in these 3 minutes, you end up with a clump of neurons that have some pretty important characteristics for serving as a model. The first of which is that they show some of the same structures that you actually see in the adult human brain. This being cortical patterning and layering of progenitor neurons to more adult neurons. So we can actually see what structures are affected by the disease. And the second is that they have the same exact genetic makeup as the individual that you took the cells from originally, meaning we get a more personalized medicine approach. We can see whether or not someone's genetic background actually affects how susceptible they would be to a drug. And so what I'm looking to do is find the best way to make these cerebral organoids by testing 2 different models. The first is trying to create cerebral organoids from people who have the disease, Alzheimer's disease patients, and comparing that to healthy organoids, taking organoids and cells from people who do not have the disease and then inducing the disease pathology in them. And we can do this by adding things like the biomarkers that are found in the blood that we've now associated with the disease. And while we're still pretty early in profiling these 2 different methods, our hope is that we can get a lab-based model of Alzheimer's disease that includes as many of these puzzle pieces as possible. So when we do drug discovery, we have the full picture, and perhaps we could even find more pieces of the puzzle. Thank you.
Okay, we are ready for our next slammer. Let's welcome Taylor Gerson.
The crown jewels disappear from the Louvre. No alarms, no shattered glass, just a group of men, a disguise, and a perfectly timed plan. A near flawless heist executed in broad daylight. Now imagine this story unfolding not in Paris, but inside of you. You are the Louvre, your cells, the crown jewels, you're the guards, and the clever thief, Shigella, a harmful bacteria that is silent, calculated, and executing the perfect regulatory heist right inside of your body. Hi, my name is Taylor Gerson, and I'm a PhD candidate in the Wing Lab, where I study the pathogen Shigella, which infects the colon, causing a disease known as dysentery. Now, this disease causes several symptoms such as bloody diarrhea, severe dehydration, and in some cases, death. Since 2020, the rise in antibiotic resistance has led to over half of Shigella infections being drug resistant, thus prompting major public health warnings like that demonstrated in number 3. To combat this, my research focuses on understanding how Shigella controls the genes that it needs to infect the host in hopes of identifying new and novel drug targets to treat these infections. So let's picture Shigella as a group of microscopic thieves, where once inside the human body, a key protein called VIR-B can act as the criminal mastermind responsible for disarming the silent alarms, or in our case, the silencing proteins that keep these harmful Shigella genes off. VIR-B, however, cannot act alone. It requires a passcode in order to disarm the system and turn these genes on, and this is where my work comes in. Displayed at number 4, my work demonstrates for the first time that VIR-B binds to a small molecule called CTP. And this is indicated by the appearance of a bullseye in the presence of hot CTP and the subsequent disappearance of that bullseye only in the presence of cold CTP. So with the help of the CTP passcode, VIR-B can disarm the system, turn these harmful genes on, and let the rest of the Shigella heist crew spring into action, thus invading our host cells and bypassing the immune system like thieves running out of the museum with billions in crown jewels. However, this is not where my story ends. Indicated by number 5, if I make changes in VIR-B so that it can no longer interact with CTP, I can prevent VIR-B from ever turning these harmful genes on. So like the detectives that ultimately apprehended the Louvre thieves, I'm starting to piece together the molecular clues of how VIR-B and CTP collaborate to hijack the human body. In the future, if we can create drugs that block this interaction between VIR-B and CTP, we can stop Shigella before it launches its next regulatory heist. Thank you.
Okay, we're ready for our next slammer. Claudia, Lou.
So I was a professional gamer and I would spend thousands of hours online training. And before matching me begins, I would hear, "Get back to the kitchen. Ugh, a girl gamer on our team? We lost already." And over time, I became quiet. I stopped speaking in chat and just played the game. And I end up losing, not the game, but my sense of belonging. For many women in gaming, this is their everyday reality. Gaming can be a space for skill development, creativity, and connection. But for women, it often comes with a cost. Prior research has shown the prevalence of this issue, but numbers alone don't tell us what it means for those who have to live it. And that's what I wanted to understand. My research explores women's lived experiences with sexual harassment in gaming and the role of allyship. I combined survey data with narrative responses. I asked women to recall a time that they were harassed for their gender while gaming. Did anyone step in? So 2 main themes emerged from this, the first being lack of intervention or support. Many women described moments where harassment was unfolding in real time and no one said a single word. Teammates stayed silent, and friends would even laugh. The silence didn't just fail to protect them, it deepened the harm. It told these women that you are on your own here and you do not belong. But another story emerged too, the presence of support. Times where a teammate said, "That's not okay," and a friend who checked in. Moments like this didn't erase the harassment, but it transformed the experience. It turned isolation into solidarity. And yet, when I was looking at my numbers, it showed that 75.7% of women indicated that other women were the ones who stepped in. And only 10.9% said that men did, even though men make up over half of the gaming population. So the findings revealed that allyship isn't abstract, it's action. It's using your voice when others are silenced. And this matters beyond gaming because the same patterns of exclusion and silence is mirrored in workplaces and schools. And they shape how gender equality is practiced across society. So we must expand on who speaks up. We must use our voice when others are silenced. And with these steps, we can help amplify women's experiences in gaming and beyond. Male allyship must grow, and gaming companies must ensure safety. Because gaming should be about skill, creativity, and joy, not survival. Thank you.
Okay, we are ready for our next slammer, Cynthia Sobko.
When you woke up today, did you know the breakfast you chose, how well you slept last night, and even how stressed out you felt during your commute could all influence your brain health years from now? These everyday experiences leave subtle footprints on the brain, footprints that we can now see and map with MRI scans. These non-invasive images allow for early detection of subtle brain changes, changes associated with stress, cognitive decline, and disease, and can inform personalized interventions before clinical symptoms even emerge. Using a comprehensive imaging approach, we can actually combine multiple MRI sequences together to capture complementary aspects of brain health. For example, we can use high-resolution structural MRI to characterize the shape and thickness of gray matter. That's where the neuron cell bodies live. We can use diffusion-weighted imaging in order to map connectivity and the integrity of white matter. That's where the neural signals flow. And we can use arterial spin labeling in order to quantify blood flow in and between brain regions. Now, these techniques together just allow us a glimpse into a brain's structure, connectivity, and circulation. So then we pair that with lifestyle data and behavioral data in order to generate a personalized brain health profile. Now, for example, let's say the brain scans show reduced circulation in parts of the brain, and they had high cholesterol. We could recommend exercise to boost circulation in the whole body. Let's say another set of scans showed stress-related changes in the brain, and they had high blood pressure. We could recommend meditation to help restore balance. Now, I will be honest, those examples are a little bit general, but that's because personalized medicine is just that, highly personal. And so during my training, I will apply and expand on these MRI techniques to better understand individual pathways to both risk and resilience within the brain. This work explores how individual daily experiences can actually help us to predict neural health trajectories over time. This aims to identify early modifiable markers of brain decline and then translate them into personalized prevention strategies. So these everyday experiences leave these subtle footprints on the brain, and they can help us to transform our MRI from just a diagnostic snapshot into a dynamic feedback system. We can combine biology and behavior in order to better understand individuals' experiences and how it leads to risk and resilience. And when we combined all of this together, it allows us to truly see tomorrow's brain today. Thank you.
Our next slammer is Adrami Badamosi.
Hi, excuse me. Hi, everyone. If I asked everyone seated here $1 million question and I say, what is the most widely used material in the world? I bet many people would say water. You are not wrong, but while water is naturally occurring, concrete is man-made, which makes concrete the most widely used material in the world. Concrete built our modern world, from the bridges we cross every day, the homes where we live sometimes, the cities we admire all around the world. But that comes at an heavy cost. Concrete is responsible for more than 11% of carbon dioxide emission to the atmosphere, which is much more than aviation industry combined together. That's a danger for our world. That is very dangerous. But with concrete, there's nothing we can do without concrete. Because think about it. If we don't have concrete, how are we going to build all of these beautiful cities you're seeing all around the world? New York, the architectural edifice you're seeing in Rome and the likes. And look at Las Vegas Strip. So what are we going to do without concrete? Someone might argue that we can use steel, but steel is not going to work. So with concrete, it is very much important that concrete, excuse me. So I'll take that again. With concrete, we have to, so concrete is very much important for this world, and we can't do without concrete because it contributes more than 11% of carbon dioxide into the atmosphere. So that is why my research focused on using supplementary cementitious materials in place of cement with alkali activators. Because when we use supplementary cementitious materials, this question might be asked, why can't we discard concrete? Why can't we throw concrete away? We can't throw concrete away because it is very important. So I'm replacing concrete with supplementary cementitious materials. And we use these supplementary cementitious materials in combination with alkali activators. So when we use them together, we form a new form of material known as UHPC. This UHPC is far stronger, durable, and much more sustainable, which is the word. So what I'm trying to do here is I've identified more than 100 different mixes, because out of these 100 mixes, I want to pinpoint and optimize which of them is good for the engineers, for the contractors, and for the government officials so that we can know the exact mix that we can use for this new type of concrete. Now, imagine you're interacting every day with infrastructures that you know is not able to cause harm and dangers to your health because there's no cement, there's no CO2 emission to the atmosphere. And that is what this research focuses on. This research brings us very close to this vision of turning waste into strength, where strength drives sustainability. And also, with this research, I'm not just trying to reimagine concrete, I am thinking about the foundation of our planet future. Thank you.
Thank you. Okay, can we give a round of applause to all of our slammers? Okay, I want to thank and congratulate all of the students who took the time to compete today. I know that this is not an easy task, but you did it. I would like to thank our judges for taking the time to judge this session. We could not have done it without you. Judges, we will give you about 5 minutes to tally your scores. While the judges finish entering their scores, we would like to invite the audience to vote for the Audience Choice Award. Please scan the QR code and cast your vote. We will announce all the winners in just a few minutes. Okay, now is the moment we have all been waiting for. It's here, and we are going to announce our winners. Once we call your names, please come to receive your certificate and stand to take a photo. We will announce our winners now. Our audience choice winner. Our audience choice winner is Taylor Gerson. Congratulations. Oh, yeah. Our third place winner is Catherine Oberg. Congratulations. Our second place winner is Lucas Richardson. Congratulations. And our first place winner is Taylor Gerson. Welcome back for another photo. Yes, congrats. Congratulations to all of our winners. We would like to thank our judges for taking the time to judge our slammers today. Without you, this event would not be possible. We'd like to thank the entire Graduate College team for making this event come to life, but it's not over yet. We would like to invite everyone to come back for the finals right here at 4 p.m. tomorrow. Thank you again for coming, and hopefully we'll see a lot of you tomorrow. Have a great day. Thank you.